What if we swapped our sun with other objects in the universe? Every second, our sun pumps out around 3.8 times 10 to the 26th watts of energy, enough to keep Earth warm, power life, and drive our climate. Without it, our planet would be a frozen rock drifting in space. Now imagine this. Tomorrow morning, you wake up, walk outside, and realize the sun isn't there anymore. Instead, something else, a completely different cosmic object, is sitting in its place. Could we survive? Could Earth's orbit stay stable? Would the planet instantly freeze, burn, or get ripped apart? To answer that, we're going to run a thought experiment. We'll swap our sun with various real objects from across the universe and see what happens. No science fiction here. We'll use real physics and real data. The thing is, our sun isn't just any star. It's a G-type main sequence star, around 1.4 million kilometers wide and 4.6 billion years old. Its mass is about 330,000 times Earth's size, enough to hold the solar system together. Its surface temperature is about 5,500 degrees Celsius, producing just the right amount of heat for liquid water here on Earth. Replace it with anything else, and all those finely tuned conditions vanish. Let's start swapping. Swap the sun with a red dwarf, like Proxima Centauri. Proxima Centauri, our closest stellar neighbor, is about 14% the mass of the sun and much cooler, with a surface temperature of only 3,050 degrees Celsius. If we placed it where the sun is now, its brightness is only 0.15% of the sun's. Earth would receive about 660 times less light and heat. Result, our planet's average temperature would plummet below minus 200 degrees Celsius in weeks. Oceans would freeze solid from the top down. The atmosphere would start condensing and snowing down as frozen nitrogen. To survive, we'd need to move Earth to 0.05 astronomical units, about 7.5 million kilometers, from this red dwarf. But at that distance, tidal forces and solar flares could strip away our atmosphere over time. Swap with a blue giant. Rigel in Orion is a B-type blue supergiant about 21 times the sun's mass and 70 times its radius. Its surface burns at 11,000 degrees Celsius and its luminosity is 120,000 times greater than the sun. If Rigel replaced our sun at the same distance, Earth would instantly overheat. The temperature could rise above 3,000 degrees Celsius in hours, vaporizing oceans and melting the crust. The intense ultraviolet radiation would shred any remaining atmosphere. In fact, to get the same warmth we currently enjoy, Earth would have to be hundreds of times farther away, way beyond Pluto's orbit. Swap with a neutron star. A neutron star packs more mass than the sun, into a sphere only 20 kilometers wide. A teaspoon of its matter weighs about 4 billion tons. If we put a neutron star of equal mass where the sun is, its gravity would still hold planets in orbit. But there'd be almost no visible light, only high-energy radiation like X-rays and gamma rays. These rays would sterilize Earth's surface in minutes. The night sky would be pitch black, except for a faint, deadly point of radiation where the sun used to be. Temperatures would plunge to minus 200 degrees Celsius almost immediately. Swap with a black hole of equal mass. A black hole the mass of the sun would have a Schwarzschild radius of just 3 kilometers. From Earth's perspective, gravity would be unchanged, so our orbit stays the same. But there's no light, total darkness. We'd freeze solid within weeks. The only glow might come from any infalling matter forming an accretion disk, but with no nearby gas, even that would fade quickly. Swap with Jupiter. Jupiter is huge for a planet, but tiny compared to the sun. Only 0.1% of the sun's mass. If Jupiter replaced the sun, Earth and the rest of the planets would lose the gravitational anchor keeping them in place. We'd drift off into space almost immediately. No heat, no light. Earth becomes a wandering ice ball. Swap with a white dwarf. White dwarfs are the collapsed cores of stars like our sun after they die. Sirius B is about the same mass as the sun, but only 12,000 kilometers wide. If we swap the sun for Sirius B, the gravity would be the same, so our orbit stays stable. but its surface temperature is around 25,000 degrees Celsius, so it emits a lot of ultraviolet radiation. Despite being hot, its small size means it only emits about 1% of the sun's energy, not enough to keep Earth warm. We'd still freeze, but we'd also get a dangerous dose of UV light. Swap with a supermassive black hole. Sagittarius A, the black hole at the Milky Way's center, has a mass about 4 million times the sun's. Place it where our sun is, and the result is catastrophic. Its event horizon would be about 12 million kilometers wide, bigger than the sun's diameter. Earth would be well inside the region where orbits become unstable. We'd spiral in and be torn apart by tidal forces. There's no surviving this one. Swap with a quasar. A quasar is an active supermassive black hole with a blazing accretion disk, outputting more energy than entire galaxies. Put a quasar at the sun's location. Earth would be bathed in radiation billions of times stronger than sunlight. The atmosphere would be stripped in seconds. The surface would be sterilized instantly. It wouldn't just be too hot, it would be a particle and radiation storm beyond survival. Swap with Betelgeuse. Betelgeuse is a red supergiant, about 764 times the sun's radius. If it replaced our sun, its surface would extend beyond Jupiter's orbit. Earth would be deep inside the star's outer layers. We'd be instantly consumed. No suspense here. So, what's the takeaway from this cosmic swap game? The sun is exactly what Earth needs for life. Its mass, distance, and energy output sit in a narrow range where liquid water, a breathable atmosphere, and complex ecosystems can exist. Swap it with a cooler, dimmer star, and Earth freezes. Swap it with a hotter, brighter star, and Earth burns. Swap it with exotic objects like neutron stars, black holes, or quasars, and life ends instantly. Even small changes in the sun's brightness, as little as 1% over centuries, can cause ice ages or significant warming. That's how sensitive our climate system is. When scientists modeled the faint young sun about 4 billion years ago, they found that the sun's output was only 70% of today's. Earth should have been frozen, but geological evidence shows liquid water existed. The explanation? A thicker greenhouse atmosphere helped trap heat. That's how finely balanced the system is. So while it's fun to imagine swapping the sun for a quasar or a red dwarf, the truth is simple. The sun we have is a rare kind of stability in a universe full of extremes. If you ever look up and think the sun is just a normal star, remember this: swap it for almost anything else in the universe, and Earth either freezes, burns, or gets torn apart. We're not just orbiting any star, we're orbiting the right star in the right place at the right time.